Say hi, Evan.
Hi, Jane.
Okay. Okay. We're going to be multiplying, dividing, simplifying radicals. So we're going to start with a little game of name that property. Pause. Resume. Okay. What I'd like you guys to do is pause the video right now, copy down what you see on the screen, and we're going to play a little game of name the property. So pause and come back. The first one is going to be equal to the square root of 4 times the square root of 7 written separately. And if you have the square root of a product, that's equal to separating them out into different square roots. This is called the product property of radicals. An important one that we have already used several times. Okay, the second one, if I have the square root of 5 divided by 9, that's equal to the square root of 5 over the square root of 9. We have used that as well when we take the square root of a fraction. We take the numerator and denominator separately. If this one's the product property of radicals, this new one is called the quotient property of radicals. Quotient property of radicals. This next one, if I say that 3 radical 5 times radical 6 equals this, 3 times radical 5 times radical 6, regrouping the radical 5 and the radical 6. That is a change in grouping symbols and nothing else. So that is not a new property of radicals. That's actually an old property of multiplication. That is the associative property of multiplication. Okay, I'm going to pause the video. You're going to write 2 more of these down. Okay, resuming. These are the next 2. Pause the video, write these down, and then come back. What we're going to say is that the first one is equal to, you can see kind of the order is weird. I can actually replace these 2 and switch them around and make it 4 radical 7 times radical 3. That is switching in order, and that's commutative property of multiplication. And then lastly, I have 5 radical 2 times 3 radical 8, and I'm going to say that that is equal to 5 times 3, the ones that aren't radicals, times radical 2 times radical 8, kind of grouped like that. And we're going to say that is both the associative and the commutative. We've actually switched the order and regrouped stuff. So both the associative and the commutative properties of multiplication. And that's going to kind of inform us, this example here, it's going to tell us how we're going to be multiplying some of these things. So let's go back to multiplying and dividing radicals, which is what the topic is all about. We're just going to do some examples here. Number 1 of our new examples is to simplify 5 radical 3 times 8 radical 21. Well, if I do what I did up here in this highlight, what I am going to do is take the constant parts, the 5 and the the integer parts, 5 times 8. I should even say the rational parts, that's probably better. 5 times 8 times, and I'm going to group together the radical 3 times radical 21. I'm not actually changing anything other than just changing which order I'm multiplying in, but I can do that with multiplication. 8 times 5 is 40. Then I have a big square root. When I multiply radicals, I combine them together. I have 3 times 21. Now, I could make that radical 63, but I could just stick the 3 times 21 in. Because really, what is 3 times 21? If I break up the 3 times 21, I have 3 times 3 times 7. And these are going to come out and multiply into the 40, giving me a 40 times square root of 3 times 3 is just 3. And then we leave behind the radical 7. 3 times 40 is 120, radical 7. And that's it. For another one, let's actually go back up to the one we had up above, 5 radical 2 times 3 radical 8. Again, 5 times 3 is 15. 2 times 8. If I actually multiply the 2 times 8, I get the square root of 16, because 2 times 8 is 16. And this is really 15 times 4. Square root of 16 is 4, and 15 times 4 is 60. third one, we have radical 10 over 3, all under a radical. Should write a giant radical. Times radical 27 over 32. Well, what I can do is multiply the two fractions together. 10 over 3 times 27 over 32. Put it all under one radical so you can cancel your fractions. The 3 and the 27 cancel to 1 and 9. The 10 and the 32 can reduce to a 5 and 16. And then I end up with the square root of 45 times 16. Now I can separate this into different radicals. 45 and radical 16. Radical 16 is 4. Square root of 45 I can think of as the square root of 9 times 5. And the square root of 9 is 3, leaving behind 3 radical 5 over 4. Number 4. Let's do radical 75 over 2 radical 18. We're going to simplify this. Okay, radical 75 I can think of as the square root of 25 times 3 over 2. Radical 18 I can think of as the square root of 9 times 2. I end up with square root of 25 is 5. Radical 3 over square root of 9 is 3. 3 times 2 is 6. And I have 6 radical 2. So we have this massive rule in Algebra 1 that we cannot have radicals in the denominator. And this is a radical in the denominator. This goes back to the days of old. If you want to go ask Miss McCarthy why you can't have radicals in the denominator, this has to do with the fact that it really sucked to divide by 1.47 or 1.414 something if you want to come up with an approximate value. So what you had to do is you had to find a way to move that radical to the numerator, and here's how they did it. They took this and they multiplied by 1. When you multiply something by 1, you multiply it by itself. But if I rewrite this as 5 radical 3 over 6 radical 2, and I change 1, I'm going to multiply, instead of 1, I'm going to multiply by radical 2 under radical 2, because this fraction is 1. If I multiply by radical 2 over radical 2, okay, sometimes I see people do this. They're going to cancel the, okay, well that's pointless. That's just going to get us back to where we are. What we're going to do is we're going to multiply across like we multiply fractions, this and this. When I do that, I end up with 5 radical 6 over, and then this is still 6, but times 2, because the square root of 2 times the square root of 2 is 2. Simplify this, 5 times the square root of 6 over 12, and now I have it, 5 radical 6 over 12. By the way, the coefficient of radical 6 is 5/12, so this is also known as 5/12 radical 6. But we're not going to write it like that. We're going to prefer to write it like this. So to just kind of give us a little bit of a review of stuff we did before, we want to review what a simplified radical is, because you're going to see simplified radicals a lot now. All radicals must be simplified. 3 rules. Number 1, we've already used one. Let's use A. No radicand. Radicand is the thing under the radical with a perfect square factor. Second one, no fraction under radical. We've seen that before. And the third one that we held off until now, no radical in the denominator. So let's practice that again. This next one, number 5. The square root of 2 and 2/3 times the square root of 1 and 1/4. I know we don't like mixed numbers, so let's convert them to improper fractions. 2 and 2/3 is 8/3, and 1 and 1/4 is 5/4. Let's combine those into one radical and make it 8/3 times 5/4. Do a little bit of canceling. 8 and 4 become 2 and 1. I end up with the square root of 10 over 3. Now I'm splitting up those square roots and see the square root of 10 over the square root of 3. We can't allow radicals in the denominator, so what I'm going to do is take this and I'm going to multiply it by this part. Radical 3, but I have to multiply the numerator by radical 3 to keep this value of fraction equal to 1. Okay, multiply across, get radical 30 over, and then radical 3 times radical 3 is 3. And that's a simplified result. Evan is back. Say hi, Evan.
Hello.
No, you need to say it louder because there's a mic here.
I don't like my voice on my...
You don't have to listen to it, Evan. Okay, number 6, we're going to multiply. And we're also going to assume variables are positive. So, we're going to multiply is 4 radical a squared b squared times 3 radical b. Well, radical a squared b squared is just ab, so we have 4ab times 3, and then still times radical b. And 4 times 3 is 12, ab, then radical b, and that's it. That one's pretty easy. The next one, we're going to do radical x times radical x minus 3. This is a distributive property. I'm going to have to take this and distribute it to both the first and the second term of the binomial that follows. Evan, what's the square root of x times the square root of x? Yeah, that's just going to be x. Multiply the square root of a number by itself and you get that number back. So don't make this the square root of x squared. That's redundant. What does redundant mean, Evan?
Not needed.
Not needed. Kind of saying the same thing. So just x minus, and then 3 times radical x is just 3 radical x. And that's really it. That's good enough for now. We'll end there and get you guys started on the homework.